Properties of polynomials. All right, so for this section, we're going to be talking about polynomial functions. And in this particular video, we'll talk about the properties of polynomial functions, what they are. And in further videos, we will talk more about the graphing of polynomials and the nitty-gritty details. So properties of polynomials. What are polynomials? Well, once you get to calculus, you'll feel like polynomials are the best functions ever. They're essentially the simplest functions. They are the nicest functions, if you will. They're functions where the exponents on the variables are positive whole numbers. That means that there's no fraction exponents, there's no negative exponents. On the variables, that is. There are no variables in the denominator. There are no variables under a radical. Radicals, by the way, those are those square root signs. So let's look at a polynomial and talk about a few more pieces that the polynomial has. The function I'm going to use when I talk about this, I'm going to use f of x equals 3x cubed plus x minus 7x to the fifth. The degree of a polynomial is the highest power of x. So there's an x cubed, an x, and an x to the fifth. Highest power is 5. So that's the degree of this polynomial. The leading term of a polynomial is the term containing the highest power of x. So terms are separated by pluses or minuses. This is one term, this is another, this is the third. There are 3 terms in here. The term that has the highest power of x is negative 7x to the fifth. And leading term, I'm going to abbreviate with LT, and for this next one, leading coefficient, that'll be LC. Right, so this entire thing here is the leading term, and the leading coefficient is just the coefficient of the leading term. So if the leading term is negative 7x to the fifth, then the coefficient is negative 7. So LC is leading coefficient. So what I want to point out here is that the word leading can be a little bit misleading, if you will, because leading sounds like it's in front. And if I look at this polynomial, it's not in front. Leading terms don't have to be in front. Typically, we write polynomials in standard form, which is with their powers descending. So we write the highest power first, negative 7x to the fifth, then the next highest power, 3x cubed plus x. So we use the word leading because oftentimes the highest power is the one we write in front. It doesn't have to be, but it oftentimes is, if you're worried about the terminology. So let's look at a few examples, determine whether or not they are polynomials, what their leading term is, what their degree is. If I look at this guy right here, I am trying to determine whether or not it's a polynomial. So I ask myself, hey, are there any negatives or fractions in the exponents on the variables? Nope. Those variables all have whole numbers, 1, 3, and 2 for the exponent. Are there any variables in the denominator? There is a denominator, but there's no variable in it. It's just a 3. So that's fine. We're good. And are there any variables under radicals? Nope. So this is a polynomial. The leading term is the term with the highest degree, which is right here. Negative 2x cubed. The degree of the polynomial is 3. I didn't leave room here for a leading coefficient, though I should have. The leading coefficient on this guy is just the coefficient on the leading term, which is -2. For this next one, there is a clear issue right here, right? There's a radical and a variable inside the radical. That makes it not a polynomial. We can't answer these questions here if we don't have a polynomial. These questions are only relevant if there is a polynomial. Looking at this next one, is it a polynomial? Looking at the exponents, uh-oh. We have a 1/2 in the exponent. And part of our rules say that the exponents have to be positive whole numbers. Can't have fractions in an exponent to be a polynomial. So this is not a polynomial. And again, we can't answer these questions. Polynomials really are just the most basic of functions. They're very, very basic, simple functions. So let's look at some properties of polynomials. Polynomials are what we call continuous and smooth. Continuous and smooth. Let's talk about both of these properties. Continuous. This is going to mean there's no breaks in the graph. The graph can be traced without lifting our pencil. I'm going to pause the video, draw a few graphs, and then we'll talk about whether or not they are continuous. All right, so let's look at these graphs that I've drawn. We want to be able to trace these graphs without lifting our pencil. If we have to lift our pencil to trace it, then they are not continuous. So looking right here, trace, trace, trace. I have not needed to lift my pencil. This guy is continuous. Over here, trace and uh-oh, I can't get to this second piece without lifting my pencil up. So this guy right here is not continuous. Zoom in. Here, trace, trace, trace. Uh-oh, I can't get up here without lifting my pencil. So that one is not continuous as well. For this graph, trace, 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 trace. Oh, yep, we can trace the whole thing. No problem. Continuous. So these two graphs are continuous. These are not continuous. Now, that doesn't mean that both of these are graphs of polynomials, although one of them could be. There is another requirement, and that requirement is that the graph is smooth. So in order to be smooth, we need to have rounded curves. We don't want any cusps or corners. And you might be wondering, hey, what's a cusp versus a corner? So a cusp is going to be when you have something that's kind of curvy, and then you like go down like that. So this little pointy point right here, that's a cusp. A corner, on the other hand, is when you have two straight pieces that join each other. So I have a straight piece and a straight piece right here. This is a corner. I'm going to pause the video real quick. I'm going to draw 4 graphs and we'll talk about whether or not they are smooth. All right, let's look at these graphs. So looking for no cusps or corners. If you look at this first one, uh-oh, there's a corner. So this one is not smooth. This next graph, there are no cusps, there are no corners. This is a smooth graph. On the third graph, right there, that's a cusp. So this thing is not smooth. This last one, there are no cusps, there are no corners. This is a smooth graph. So if we're looking at these and wondering which of these could possibly be polynomials, which of these could be graphs of polynomials, boop, boop, boop. Well, none of these that are not continuous can be polynomials. Those can't be polynomials because they're not continuous. These aren't polynomials because they're not smooth. Let's look at these remaining four and determine if they could possibly be a graph of a polynomial. Right here, this guy's not smooth. He has corners, so this one can't be a polynomial. Not smooth, so he's not a polynomial. This guy here, he is smooth and he is continuous. So this could potentially be a graph of a polynomial function. It is continuous and smooth. So that is potentially a polynomial. Down here, both of the examples left over are continuous. So both of these down here could potentially be graphs of polynomials. So that's the kind of look you're looking for: smooth, continuous. If we look at these functions, we're going to determine whether or not they're polynomial functions, just like we did above. We'll do it real quickly. All right, this guy is continuous. It's one piece. There are no cusps. There are no corners. This is a polynomial. This guy here looks like there's a break in the graph right here. I can't trace the whole thing without lifting my pencil up, so it's not continuous. Therefore, it is not a polynomial. Up here, we have ourselves a cusp. So it's not smooth. This graph is not smooth. It cannot be a polynomial. This last one, it is continuous. It's one piece. It is smooth. This could be a polynomial. So those are the basics of polynomials, of what their functions look like, both in function form and graphically. They're just very, very nice functions. In future videos, we're going to talk about how we can graph functions and polynomials, and it's fun. I think it's fun, at least. So join me in another video and we will discuss it. Bye.